There are two experiments you'll be carrying out this semester, and these two experiments, you'll be either asked any of them in your exams. Alright, so the two experiments you'll be considering this semester, number one is, please listen, the two experiments you're going to carry out this semester, you've done the first part, the second part, after the second part, you submit your manual. Number one is refraction on plane surfaces. Refraction on plane surfaces by Snell's law. And number two experiment, which is the second one on electricity, is verification of resistance explained by Ohm's law. So these are the two experiments we carried out. Refraction on plane surfaces explained by Snell's law, and verification of resistance explained by which law? Ohm's law. Let's start with the first one. The first one is the one you did. Everybody has done refraction on plane surfaces. It's either you did experiment L1, L2, L3, L4, or L6. Nobody did L5. L5 is on mirrors, L6 is on mirrors, but some persons did L6. Alright? So the aim of this class is to explain these two different experiments, and we'll start looking at the calculation, or we'll start looking at the plotting of the graphs. We'll look at calculation of slopes. We'll look at how we can calculate error in slope, error in intercept, and we'll review on how we can plot a standard graph. Now, if I explain after today's class, please listen up. After today's class, you should be able to calculate error in slope. In your second semester physics practical exams, after plotting your graph, they will ask you to deduce the error in your slope. So, at the end of today's class, even if you don't get anything, what I want you to get is how to plot a standard graph, which scale to use, how to calculate error in intercept and error in slope. If you know this, I am justified that you were present for today's class. So let's start. Refraction on plane surfaces. Refraction on plane surfaces. There are two laws of refraction. Two laws of refraction by Snell's. There are two laws of refraction. Two laws of refraction by Snell's. Number one law states that in your exam you can state the first or the second. Alright? The first law of refraction by Snell's states that the first law of refraction by Snell's, it says that the incident ray, the first law of refraction by Snell's, it says that the incident ray, the normal, and the refracted ray. I said something. The incident ray, the normal, and the refracted ray at the point of incidence. The incident ray. This is my incident ray. The incident ray, the normal is always at 90 degrees. This is the normal N. This is the incident ray I. The incident ray, the normal, and the refracted ray. Please listen up. And the refracted ray at the point of incidence. This particular point is called the point of incidence. All lies on the same surface. The incident ray, the normal, and the refracted ray at the point of incidence all lie on the same surface. This is called the refracted ray. Alright? Did you get the first statement of the law of refraction? Yes. The incident ray, the normal, and the what? Refracted ray. Is it refracted or reflected that I said? Refracted. This is because of your exams. Don't say reflected. If you say reflected, it means you're talking about Snell's law of reflection. The incident ray, the normal, and the refracted ray, at the point of incidence, all lies on the same what? Plane. The same surface or the same plane. Alright? This is a smooth surface. It can be a mirror, it can be a glass block, as far as a smooth surface. Are we following? This is the first statement of the law of refraction. The second statement of the law of refraction, it states that the ratio of the sine of the angle of incidence, or the incident angle, whichever one you want to use. The ratio of the sine of the angle of incidence, the ratio of the sine of the angle of incidence to the angle of refraction. The ratio of the sine of the angle of incidence to the angle of refraction is equal to a constant for all light rays moving from one medium to another is equal to a constant for all light rays moving from one medium towards another. The ratio of the sine of the angle of incidence to the angle of what? Refraction is equal to a constant for all light rays moving from one medium towards another. Mathematically, whenever you state any law, you must give a mathematical what? Expression. Mathematically, second law of Snell is telling us that sine I to sine I is equal to a constant n, where this n is called the refractive index. When this n is called the refractive index. These are the two statements of the laws of refraction. Now, what is refractive index? Refractive index is defined, the symbol for refractive index is small letter n. Refractive index is defined as the extent to which the speed of light. Refractive index is defined as the extent to which the speed of light is reduced as it moves from one medium to another. Refractive index is defined as the extent to which the speed of light is reduced in case you're asked in practical exams. They might give you a statement, they can ask you to define it. What is refractive index? The extent to which the speed of light is reduced as it moves from one medium towards another. The symbol for refractive index is what? N, small letter n. Are we following? Are we following? Did we get the statement? Yes. Alright, so since we have talked about the two laws of refraction, please listen up. What is refraction and what is reflection? I am looking at the important aspects that you can come across in your practical exams. That is the aim of today's class. This class may not be repeated such that those that miss the class can stream the video in the YouTube channel. Now, what is refraction and what is reflection? You'll be asked the same question in your practical exams. What is refraction? Refraction of light is defined as the change in the direction of light rays. Refraction of light is defined as the change in the direction of light rays. Refraction of light is defined as the change in the direction of light rays as it moves from one medium to another. Refraction of light is defined as the change in the direction of light rays as it moves from one medium to another. While reflection of light is defined as the repropagation or the bouncing back of light rays. While reflection of light is defined as the repropagation or the bouncing back of light rays as it moves from one medium to another. The bouncing back of light rays or the repropagation of light rays as it moves from one medium to another is called what? Reflection. But the change in the direction of light rays as it moves from one medium to another is called what? Refraction. Let's illustrate the phenomenon called refraction of light. Let's see how light. I have a rectangular glass block. I have a rectangular glass block. This is experiment L1. Alright, well, we've not started yet. I just want to explain the phenomenon of refraction. This is a rectangular glass block. Now look at this. If you pass light rays at an angle of 30 degrees, if I pass light rays to this glass block, this is an incident angle or an incident ray. See, the one you see having an arrow, this arrow, the line with an arrow is called a ray. Alright? But this angle is called the incident what? Angle. Let's take this incident angle to be 30 degrees. This is the incident angle. This straight line is called the incident what? Ray. Now look at this. There is a normal. The normal is always at 90 degrees to the glass block. Now look at this. When light rays move from air to glass, this is glass. When they move from air to this glass, when light rays move from air to glass, air, listen, there's something they say. When they say something is denser, it means it's heavier. When they say something is less dense, it means it's less heavier. Now, air is less dense than glass. Glass is denser than what? Air, because glass is heavier. Now, it's just like, look at this. When you flash light rays towards a mirror, it will reflect back into your eyes, isn't it? And you strain your eyes, like you glitch. Why? Because the eye is also a reflecting surface. But look at this. If you flash light rays in this experiment, look at what's happening. You flash light rays at this glass block. These light rays, since they are coming from air to glass, after hitting this glass, these light rays are supposed to go in this direction. these light rays are supposed to go in this direction. But because this glass is heavier than air, there will be a change in their direction because it is now in contact with something that is heavier, isn't it? Now, when these light rays are in contact with this glass, instead of them going towards this direction before they come out from here, they will change in their direction and they will start going this way. There is a change in the direction, then they come out in this direction. This is the this is the incident, this is the direction they are supposed to move. But because they come in contact with something that is denser than air, they will change in their direction, reducing this angle that is 30 degrees, this angle that is 30 degrees. Since, listen, when light rays hit a smooth surface, some rays are reflected, some rays are diffracted. So the incident angle that is 30 degrees, the refracted angle will be half the incident angle. The refracted angle will be half the incident angle. So if you use something lower than 30, it means you will not have any refracted angle. But if you use something higher than 30, are you going to have a refracted angle? Yes. Now, understand the basic phenomenon here. When light rays come in contact with this glass block, what happens is very simple. These light rays are supposed to go towards this direction. But because this glass is heavier, it's thick, they will change their direction. Instead of them going towards this direction, they will change and go towards this direction. It means this particular ray is called the refracted what? Ray. It means they will not move towards this direction, which is the angle at which they are incident on this, but they are diffracted. Now, when they exit this particular glass block, when they come out like this ray is called the emergent ray. The one coming out is called the emergent ray. And the angle at this emergent ray, this emergent angle is the same. The emergent angle must be the same as the incident angle. If the incident angle is 30 degrees, it means the emergent angle will also be what? 30 degrees. But the refracted angle is half the what? Incident angle. The refracted, you know why it is half? Because some rays, please listen attentively. Why is this angle half? Why is the refracted angle half the incident angle? Because some rays are reflected. Alright? Now, this particular ray has come in contact with something heavier. This direction is the initial direction, but it's going to change and becomes refracted. And when it comes out from this part, you have an emergent angle that is the same as the what? Incident angle. That is the phenomenon, or that's the experiment we are carrying out in experiment L1, L2, and L3. The aim of experiment L1 to L6 is to deduce refractive index. We cannot get refractive index if there is no refraction. If the speed of light at which we see this thing, we said, I told you refractive index is how much the speed of light is what? Reduced. If I have this speed of light that is coming with a high speed and they hit this glass surface, imagine if you're running with a high speed and you hit the wall. Will you go through the wall with that same speed? No. You will change direction and look for where there is space. Because your body is now in contact with something heavy. Even if you're blind and you walk towards a wall, you're blindfolded, you're walking towards a wall and you hit a wall, you will start looking for where there is space. Now that's what these light rays do. When they are coming with an angle with a velocity with a speed of let's say 500 meters per second, when they are in contact with this glass block, this speed, will it still be the same 500 meters per second? No. It is going to what? Reduce. Now when it reduces, it means that there is a refracted what? Ray. So for you to get the refractive index, you must first of all get a refracted what? Angle or a refracted ray. We cannot deduce refractive index without getting a refracted what? Ray. Do you understand the phenomenon? Yes. Any questions? Please, who does not understand? Do you understand the phenomenon? Yes. Okay. Let's proceed. Let's look at, this is what is happening in experiment L1, L2, L3. After explaining Ohm's law, we'll go over to the graphs, plotting L1, L2, L3, L4, L6. Alright? So, this is all about Snell's. What Snell's is telling you, Snell's law of refraction is telling you that when there's an incident angle, there must be a refracted angle and a what? Reflected angle. But why am I not showing the reflected angle? There's supposed to be a reflected angle like this. Why am I not showing the reflected angle? Why? Because what we are talking about is refraction on what? Plane surface. So, you know that there is a reflected angle, but my interest is which angle? Refracted angle. Are we following? Alright, so let's discuss Ohm's law. Let's discuss Ohm's law. Of resistance is same as the definition of Ohm's law. Alright? So let's state Ohm's law. In your exams, you'll be asked to state Ohm's law. Now, Ohm's law states that the potential difference across a metallic conductor, the potential difference, PD, the potential difference across a metallic conductor, the potential difference across a metallic conductor is directly proportional to the current flowing through the conductor. The potential difference across a metallic conductor is directly proportional to the current flowing through the conductor and inversely proportional to its resistance provided temperature, area, provided, where do you stop? Is directly proportional to current flowing across the metallic conductor and inversely proportional to the resistance, provided that temperature, area, provided that temperature, area, and other constraints are kept constant. Provided that temperature, area, and other constraints are kept constant. That is the statement of Ohms. I'm going to take it again. Ohm's law states that the potential difference across the metallic conductor is what? Directly proportional to the current across the metallic conductor. And what? Inversely proportional to the what? Resistance. Provided that what? Temperature, area, and other what? Constraints are kept constant. Mathematically, whenever you state Ohm's law, mathematically, you must give an expression. Mathematically, V, potential difference. The symbol of potential difference is V. Potential difference is directly proportional to current I. And we said it is inversely proportional to what? Resistance. If I introduce a constant, alright, please listen up. If I introduce a constant, call it R. This constant is called the resistance of the conductor. This formula becomes V is equal to IR. If you make R subject of formula, V is equal to IR is the formula for Ohms. This is Ohm's law. V is equal to IR. Alright? V is equal to IR is the formula for Ohms. If you make R subject of formula, I have that R is equal to V over what? R. It means that resistance is inversely proportional to current, but it's a direct relationship to what? Voltage. Now, let's take circuit, a typical DC circuit, to explain this particular phenomenon of Ohms. A simple DC circuit. Hope you know what's a DC circuit. A DC circuit, the meaning of this is called what? Direct current circuit. I'll take that off. Alright, so let's consider a DC circuit. If I have a DC circuit is just a direct current circuit in which current flows in one direction, in case you are asked. A DC circuit is, the meaning of DC is called direct current circuit. A DC circuit is defined as a circuit in which current flows in one direction. The flow of current is unidirectional. A DC circuit is a type of circuit in which the flow of current is in one direction. The DC circuit is composed of 4 components or devices. Number 1, resistor. Number 2, a battery. Number 3, am I too fast?
Yes.
Where did you stop? Okay, but you got the definition of a DC circuit, right? A DC circuit is a circuit in which the flow of current is in one what? Direction. Did you get that? Yes. Components of a DC circuit are resistors, battery, switch, and optionally an LED. You can decide to add an LED or decide not to add an LED. Alright? LED, light emitting diode. L, capital letter L, E, and D. Okay, a simple DC circuit. Let's look at a simple DC circuit. Please look at this. A simple DC circuit is composed of a resistor, a switch, and a battery. Please listen up. This is the positive, this is the negative. This is my resistor. This is the switch. And this is my battery. Alright, please listen up. This is a simple DC circuit that is composed of a resistor. If you don't want to draw it like this, the symbol for a resistor, please look at what I want to draw first before you draw. If you want to draw this, you start up and end down. I started up and I ended where? Down. If you start up and end up, it's not called a resistor. You're drawing what is called a transformer or a solenoid. Solenoid is what starts up and end up. But if you start up and end down, it's called a what? A resistor. If you know this one, you're going to get confused. Draw this with the one that has box. Use a box to represent your resistor, like the ones in the textbooks. It's either you use a box or you use this. This is the symbol for a resistor. Are we following? Are we done with the circuit? Are you done? Are you done?
No.
Okay, look at this. In this particular DC circuit, this is the battery. The longest terminal is the positive terminal, the shortest terminal is the negative terminal. Current moves from positive to where? Negative. Now, when current moves in this direction, this resistor opposes the flow of current. Look at, if you observe, the movement of current in a DC circuit is in one direction. It must be from positive to where? Negative. But if it was in an AC circuit, alternating current circuit, it is a reverse. In AC circuit, current can move from positive to negative or from negative to positive. In AC, current can move from back to forward or from forward to backward. Alright? That's why the flow of current in an AC circuit is said to be reverse or non-unidirectional. Alright, look at this. What I want to explain from the statement of Ohms, please listen up. Ohms is saying that if I have a battery, let's say this battery is 3 volts. The voltage of this battery is 3 volts. Please listen up. If this battery is producing a potential difference of 3 volts, please listen. It means that I have current I flowing in this direction. Like this. I have current I. Now, when this current produced by this battery of 3 volts, let's say this battery is producing a current of 3 ampere. Now, when this current gets to this resistor will oppose some current. It means it will not allow all the current to pass through. It will oppose the flow of some current and allow maybe half to pass through. Now, when that half has passed through, the current has passed through and comes to this switch. If you observe, this switch is open. When a switch is open, it's just like when you put off a bulb. When you put off a bulb, there is no current in that bulb. But when you put on the switch, there is what? Current. Now, when you put on this switch is like an open. This is said to be an open circuit. But if I put on the switch, I close it. The switch is said to be closed. Now, current can flow and come back to the negative what? Terminal. Now, what Ohms is saying? Ohms is saying that the potential difference flowing through this circuit is the same as the what? Current. It means the potential difference is the voltage in this battery. The battery is 3 volts. It means this 3 volt battery must supply a current that is equivalent to this amount. 3 volt battery must supply a current of 3 ampere. 50 volt battery will supply a current of what? 50 ampere. But when it gets to this resistor, the name resistor, it opposes the flow of what? Current. The resistor will reduce the current half before crossing. That is the function of the resistor. So what Ohms is saying is that the voltage is the same thing as the what? Current. But the resistance across this circuit is half or an inverse of the voltage or the current. That is what Ohm's law is talking about. Now, from Ohm's law, let's look at something very, very basic and integral, which is resistors. See, the most important device or component in a DC circuit is called a resistor. Now, these resistors, they can be placed in series or in what? Parallel. What you need to understand is the current across resistors in series and the current across resistors in parallel. So let's consider a DC circuit where we have resistors in series and resistors in what? Parallel. Let's consider a simple DC circuit where we have resistors in series and parallel. So that when you do the next practical, you can answer the questions there. Let's consider a simple DC circuit with resistors in series and parallel. Okay, so consider figure 1. Resistors in series. Let's say figure 2. Resistors in parallel. So if I have resistors in series, resistors in series connected to a battery. Alright, let's say this is R1, R2, R3. These are in series connection. Resistors in parallel. This is positive, negative. Okay, let's say this is R1, R2, R3. Alright, so after this, then we'll delve into the experiment. L1, L2, L3, L4, and L6. What you need to understand in resistors in series and parallel, because of the next practical and because of your exams. Now listen up, very brief. We said this is an example of a DC circuit because the only component you see is called a what? Resistor. Hope you know if you don't want to use this symbol, you can use the box symbol for resistor. Alright? Now, if I have resistors in series, they have the same current. This is going to help you answer the next practical question, but different voltage. Resistors in series have the same current but different voltage. It means the equivalent resistance of resistors in series The total resistance is what we call equivalent resistance. The equivalent resistance of resistors in series is the summation of all the resistance of the resistors. R1 plus R2 plus what? R3. This is resistors in series. Now, what does it mean? Resistors in series, since they have the same current and different voltage, it means they have a higher resistance. Please take note because of the next practical. Resistors in series, since they have the same current and different voltage, it means they have a higher resistance. Resistors in parallel have the same voltage, or you can say the same potential difference. Voltage is same as potential difference. Resistors in parallel have the same voltage but different currents. Resistors in parallel have the same voltage but different currents. Since they have different currents, it means they have a low resistance. It means they have a what? Low resistance. Please take note of this statement. Resistors in series have a higher resistance because they have the same current. Resistors in parallel have a low resistance because they have different what? Currents. Are we following? The instrument that is used to measure current is called an ammeter because of your exams. The instrument that is used to measure current is called an ammeter. The instrument that is used to measure current is called an ammeter. A-M-M. The instrument that is used to measure current is referred to as an ammeter. The instrument that is used to measure voltage or potential difference is called a voltmeter. You must be asked 3 out of this instrument. The instrument that is used to detect current. The instrument that is used to detect current is called a galvanometer. A galvanometer is used to detect, not measure. The instrument that is used to measure resistance is called a Refraction bridge. You are taking it. And the instrument used to detect charge is called an electroscope. You must see 3 out of this in every past question. We said the instrument used to measure current is called what? Ammeter. Used to measure voltage is what? Voltmeter. Used to detect current is what? Galvanometer. Used to measure resistance is called what? A Wheatstone bridge. A Wheatstone bridge is the most accurate instrument that is used to measure resistance across a wide range. Please take note. Dash is the instrument used to measure resistance across wide ranges. It's called a Wheatstone what? Bridge. Are we following? Yes. An ammeter is always connected in series to the DC circuit. Please write this. We may not be able to look at it again. When you fall back to the video or you fall back to your notes, you will remember. An ammeter is always connected in series to the circuit, but a voltmeter is always connected in parallel to the circuit. A voltmeter is always connected in parallel to the circuit. An ammeter is always connected in what? Series to the circuit. That is all. Experiment L1. I'm giving you the foundation. Experiment L1. Let's see how we can plot the standard graph and let's see how you can get errors. Did you get the statement? I said, please don't juxtapose the whole statement. It's very important. Ammeter is always connected in series, but voltmeter is always connected in parallel. Those in College of Medical Sciences, your exam and graph is always coming from Wheatstone bridge. Wheatstone bridge, I said, is the most accurate instrument that is used to measure what? That is used to measure what? Resistance. In experiment L1, we are plotting a graph of cos theta against X. You know the phenomenon of refraction by Snell. We've understood the statement of phenomenon of refraction by Snell, isn't it? That if light wave are incident on the smooth surface, there will be a reflected ray, a refracted ray, isn't it? Mathematically, sin I over what? Sin R is equal to what? N. And what is that N? So for experiment L1, let's go into the graph. We are plotting the graph of cos theta against x. We've already explained the experiment. That was the statement that's end. So we are plotting a graph. Please listen on. I'll use this graph to explain error in slope. For experiment L1, this is my origin. If you see the graphs I plotted, they are very neat. Theta against x, we are using a scale from 2 cm to 0.1. 2 cm, 0.2, 0.3, 0.4, 0.5, 0. I'm going to use this graph to show how to calculate error in slope. 0.6, 0.7, 0.8, 0.9. This is cos theta axis. In your graph, it's going to be spacious. Alright? This is my origin. For this axis, the same scale 0.1, 0.2, 0.3. If you look at the graphs I plotted, please make sure yours is as neat as that. All the graphs from L1 to L6, when I calculated error in slope, I'll teach you that now so that when you see those lines I use, you understand what I did there. 0.4, 0.5, and this axis is x. It doesn't have a limit. The both axis does not have a limit because the ratio of 2 units. Alright? So now look at this. For experiment L1, we're plotting cos theta against x. Now look at this one. In case, for those persons that made a mistake, if I have 5 points, 1, 2, 3, 4, 5, and I want to draw my line of best fit, I am not interested in the line of best fit coming from the origin. My interest is that the line of best fit must go through at least 3 points. If they are marking your script, most of you did well in the practical exams. Some persons, the reason why they got to they are like surprised, they don't read the lecture, blah, blah, blah. The fault is actually from you. Now, what they are marking to you, you might think they are marking the graph coming from the origin. No. The first thing you look at in your graph is your scale, your title. They look at your line of best fit. Is your line of best fit touching 3 points? If your line of best fit is not touching 3 points, there's no way you get the full 40 marks for that graph. So the first thing I'm considering is that my line of best fit must touch at least how many points? 3 points. I am not interested, you see some persons, their graph will come from the origin, but at the end of the day, it will not go through 1 point. It will just demarcate the point like blue sea or red sea. So point to here, so point to here, it will just find the middle. And they will tell you it's correct. It is not correct, it is overwrong. Now look at this. If I'm drawing a line of best fit, let's say I'm drawing a line of best fit, just my hand, I'm using my hand to draw, so it's not that perfect. Now look at this. I want to understand. If I have a line of best fit like this line of best fit is touching only these 2 points, isn't it? It's touching 1 and what? 2. Now it's giving 1, 2, 3 on this side. If you have a line of best fit like this, it's not correct. The point that is left untouched must be evenly distributed. If 2 points are on this side, at least 1 point will be on this side. If you don't have the points evenly distributed, at least 2 here, 1 here, or 1 here, 1 here, you cannot have 3 here and 1 here. Alright? If the points are evenly distributed, you can get an accurate error in slope. You will see that your slope value will hit 1.5. Now please listen up. For experiment L1 and L2, the refractive index you have to get must be from 1.5 to 1.7. This is the refractive index of glass. What do I mean? It means that your refractive index is equal to your slope value, isn't it? You said refractive index is equal to what? Slope. Anything you get as a slope is called the refractive index. It means any slope value you get from L1 or L2. L3 you're not getting slope. L1 and L2, the slope of both graphs must be from 1.5 to what? 1.7. If you want 1.46 something, it's actually 1.5, you are still on track. But if you're getting anything 1.1, 1.2, it means there is an error from your line of best fit in case of exams. Alright, so we now understand how to draw line of best fit, isn't it? Number 1, I said line of best fit must pass through at least how many points? 3 points. So my aim is not for the graph to come from the origin. My aim is for my line of best fit to touch at least how many points? 2 points. 3 points, not 2 points, 3 points. So let's say this my 1, 2, 3 is touching 3 points. I'm leaving 1, 2 on this side. 2 here, 1 here. These are accurate line of best fit. If I want to draw my slope triangle, if you want to draw your slope triangle, I've communicated to you. If you want to draw your slope triangle must be on any 2 points that the line of best fit is touching. Look at this. If I want to draw my slope triangle, I will not start drawing from here. There is no point here. The line of best fit is touching 1, 2, and 3. So if I want to draw my slope triangle, it will come from here to this point, or from here to this point. Because the slope, this line of best fit is touching 1, 2, and what? 3. If I have another point here, like this, like the line of best fit is touching, I can draw it from this point to this point. Your slope triangle must be drawn from any 2 points that the line of best fit is what? Touching. Do we understand that? Yes. If it is not drawn from any 2 points that the line of best fit is touching, the probability or the accuracy of you getting 1.5 to 1.7 will be reduced. So many persons that are getting 1.1, 1.2, 1.3 is because of the slope triangle. Do we understand the concept of slope triangle? Yes. Error in slope. After error in slope, we've understood the whole of the class. It's just for you to know how the graph looks like. Error in slope. Where did we not get? Is there any question? Okay, error in slope. The formula used to calculate error in slope in experiment L1 and L2, the value of your slope is called the what? The value of the slope you get is called the what? Refractive index. Thank you. Now let's see how you can get error in slope. Let me erase this. Let's learn how to calculate error in slope. Although there's a video for this, but this is another added advantage or explanation. Let's see how you can calculate error in slope. Please, we understood the concept of line of best fit, isn't it? Yes. I have a concept in every tutorial. I'm not interested in how far, I want to understand it. You know how to draw line. If you observe my graphs I plotted that you see in the PDF, anybody that is not present in the tutorial will just think I'm just doing it for fun or to design the graph. They won't know because they are not in the class. So if you see them drawing it, you teach them. And if you're drawing a point, a dotted line from any point, they will not know why I'm drawing the dotted line. But please listen because of the exams. Line of best fit, slope triangle, error in slope. You must be asked to calculate error in slope in the exams. The formula to calculate error in slope is S subscript G. S subscript G is the symbol for error in slope. Error in slope is equal to 4 times width all over number of points plotted times range. Where SG is error in slope, W is called the width. N is the number of points or number of observations. Rho is the range. Rho is just H2 minus X1. Now, the issue in error in slope is how to get the width. Another name for the width is called vertical scatter. Your textbook, your manual call it vertical scatter. You can either call it vertical scatter or the width. Now, please listen. If you're done with this, please drop your pen. I want to explain error in slope. Just drop your pen and watch it. To get error in slope, let's say I plotted the graph and I have a line of best fit. And this is touching 1, that's 2, that's 3, limit 1, 2, and 3. Like this. Alright? Is this line of best fit correct? Yes. Yes. Now look at this. If this is point 1, point 2, point 3, point 4, point 5, point 6. Which of these points can I draw my slope triangle from? 0.5 and what? Or 5 and 4. Very good. Good. Now, if I want to get my error in slope, what do I do? The formula is error in slope is equal to 4 times vertical scatter. What gives students issue is this vertical scatter. And this n you're seeing here is the number of points. So count 1, 2, 3, 4, 5, 6. 6. N is equal to 6. R, which is the range, is just after drawing your slope triangle like this. After drawing your slope triangle, when you trace it down like this value here is called x2. When you trace this one down, this value is called x1. So when you subtract x2 from x1, it is what? Range. But now let's see how you can get vertical scatter. That is the aim. So that you will teach others that are not aware. Because you see some persons drawing what I don't know in their manual. I have seen a few persons' manual, And the line they are drawing is scary. It's scary. I saw somebody's graph, L4, she drew a graph like this. And it was like this. Live, I saw it. I've seen this L4. I don't know if it's correct because it's trying to read the market. Because it's the forest trader. So too much analysis of the market has affected the physics in the person. So the person has to get anything is trading. I had to correct her. But before I corrected her, she started. I said, okay, if you don't want to submit. The following day she came back and she observed that. I said, you observed that. You know when you're telling somebody, and this kind of person, imagine she's your classmate. Blind, reading blind. Then this is it. You are wrong, you are going to fail it. Now change your own. Alright, so let's get started. How do we get vertical scatter? Vertical scatter is defined. Please write this. Vertical scatter is defined as the shortest distance between 2 points on opposite sides of the line of best fit. The shortest distance. Take note of that word, shortest. Vertical scatter is defined as the shortest distance between 2 points on opposite sides of the line of best fit. The shortest distance between 2 points on opposite sides of the line of best fit. That's what we refer to as what? Vertical scatter or width. Now look at this. I have points 1, 2, 3, 4, 5, 6. Alright? My line of best fit is touching 3, 4, and what? 5. The point my line of best fit is not touching is 1 and what? 2 and what? 6. And they are evenly distributed. Now, if I want to get my vertical scatter, listen, please just listen. If I want to get vertical scatter, the shortest distance between 2 points on opposite sides. Now, I'll look at point 1, 2, and 6 are the points on opposite sides. Now, I'll look at the distance. The distance is this thing. The distance between point 1 and 6, is it closer compared to 2 and 6? 2 and 6 are 1 and 2 is closer. 2 and 6. 2 and 6. And they are on opposite what? Sides. So if I want to get my vertical scatter, I will check the point that the line of best fit did not go through, which is 1, 2, and 6. Then I will compare which one is closer, which one is shortest. The distance from point 1 to 6 is farther compared to the distance from 2 to what? 6. So 2 to 6 is closer. Now what will I do? I will take my rule. Because they said I should calculate error in slope. I will take my rule. Let me erase this value so that you see what I'm doing clearly. Because that's the same thing I do in the PDF. So you don't want to just draw any type of line and think your code must come from that particular place. Since I'm taking this point at this point, you take your rule. Please, does anybody have a rule? A long one? Anybody with a rule? Anybody? Okay, borrow rule. This one is short. Give me that one. Thank you. No, give me that one. Thank you. Now look at what I'm going to do. Since I'm taking this distance from this point to this point, I want to make this distance from this point. Look at what I'm going to do. I'm going to take my rule. I'm considering this point and this point, not this one and this one. Hope you understand. Now I'll take my rule. Draw a dotted line like dash to pass through the center of this point. That dotted line must pass. So if you see what I did, my own dotted line, it passed through the center. Not just my dotted line, because you see no line. Just draw it. Your dotted line must pass through the center of the 2 points you're considering, and it must be parallel. Look at this. I'm going to draw it to pass through the center. I'm going to keep drawing it down. It must be equidistant. It's because of my hand. Alright, look at this. It's passing through the center of this point. I will draw it to pass through the center of this one. Look at this one. I'll first of all look at it. Look at where I'm drawing from. To pass through the center, like this. Keep drawing it down. The line of best fit is not that straight because I use my hand. That's why. Look at where it ended. It ended on this y-axis. It did not exceed. Observe the dotted lines I drew. These dotted lines I drew, they are touching the 2 points. They are passing through the center of the 2 points I want to use to measure my width. Do you understand to this point? Good. Now, after using your rule to draw these dotted lines, why are we drawing these dotted lines? These dotted lines is just here to show that we calculated error in slope, nothing else. If it is a curve like L3, they ask you to calculate error in N. If it is L3, then you have the points like this. If you look at this is L3, it's a curve. L3 graph is a curve. If it's in L3, I'm considering this point and this point. What do I do? Draw dotted lines that will pass through the center of this curve. Are you seeing from this point? Draw another dotted line that will pass through the center of this one. If you see my L3, you see a dotted line like this. L3, I drew a dotted line like this. You know why I do this dotted line? Because it's a calculate error in what? Slope. So whenever you see in L2, you see me do something like this. The one of side I against side R, L2. You will see the graph I plotted very neat, and I did something like this dotted line. So you know why I did dotted line, isn't it? And you know why the dotted line is going to the center of this and this, because I'm using this point and this point to get my what? Width. Are we following? Yes, sir. Stop sleeping. Alright, so after doing this, and I told you the reason why I'm doing these dotted lines, or I'm making these dotted lines, is just to show that I can make an error in what? Slope. Now, how do I get my W? Since I'm considering this point and this point, this is the most important information. Use your rule like this. Place it on this point. Trace it to the y-axis like this. You don't make the dot, you're not making the dots. I'm just look at place this your rule on this point. Trace it to the y-axis. Let's assume that this point is giving what? 0.8. So this is 0 W. To get my W, 0.8 minus. Come down, place it like this. Look at. Read it to the y-axis. Let's assume this to be 0.65. Are we following? So 0.8 minus 0.65. Anything you get is your what? W. The 2 points you are using, just trace it to this side, trace it to this side. You have got a W. But the reason why we are doing this dotted line is to show that we can let it error in what? Slope. So the dotted line is a necessity. Yes, it's a necessity. If you see in the question, calculate error in dash or error in n or error in anything, you must look at this L3, experiment L3, they say calculate error in n, but you don't ask me for the slope. For the fact they say calculate error in n, you see like this dotted line. Whenever you see, whenever you see me use dotted line to follow the curve, this one is the curve, that's why this dotted line is the curve. This one is a straight line, that's the dotted line is the what? Straight line. Whenever you see dotted line, it means we are calculating error in what? Slope. This who does not understand. Good, that's the question somebody asked, and I was expecting somebody to ask. Now she said, what if the 2 points are just on one side and there's no point on this side? Just assume. She's just asking for assumption. You get the graph of that was L1, this L1 cos theta against x. You might have a situation where you have 2 points on this side and it's touching 3. No matter how you try, it's touching 3. Provided it's touching 3, you're cool. Right? If you have 2 on this side and there's no 1 on this side, it's not balanced. But we're actually going to get something close to 1.5 approximately. If you have 2 points, let's just consider different possibilities. If you have 2 points on this side, now she's asking, how do you get your particle scatter? If I have 2 points on this side and there's no point on this side, is this thing or is this thing? The line of best is touching 1, 2, and what? 3. If I have 2 points on this side, that's not touching. Now, how do I get my particle scatter? My particle scatter is the shortest distance. Now, since I have 2 points here and there's no point here, I'm going to consider the point it did not touch and the point it touched. Look at this point it did not touch is closest to this one it touched, isn't it? Yeah. This point it did not touch is far from this one. This one it did not touch is a little bit far from this one. So the closest is this and what? This. The closest point, if you don't have any point on the opposite side, if you do not have any point on the opposite side, please to know, if you do not have any point on the opposite side, look for the point that the line of best fit did not pass through, that is closer to the one the line of best fit is passing through. Now look at this one, this point and this point. This point and this point are closer compared to this and what? This, or this and this. So what I'm going to do, I will just draw this thing. Since I'm using this and this, I will just draw only one dotted what? Line. But if I'm considering the point from opposite side, I will draw 2 dotted lines. Do you understand? It means that in some people's graph, it depends on, don't go and copy somebody and don't know. You might see your neighbor drawing 2 dotted lines, and your own points are on one side, and you are putting person to draw 2 dotted lines. It means you don't know what you're doing. If you see somebody drawing 2 dotted lines, check your point. Do I have a point on the opposite side? If you do not have a point on the opposite side, then consider the closest point on one side. You can consider this and this. This is the best option to go with. Who can tell us the second option? Is it this one and this one? Or this and this? This and this. Good. So if you don't go with this and this, you go with this and what? This. It is only when you have the points evenly distributed on opposite side that you can draw 2 lines. If you look at the experiment L3 I did, experiment L3, that curve, if you look at the PDF, I did only 1 dotted line. I did not do the second one. Who knows why? Because I considered 1 point did not touch and the point it was touch. Thank you. So if you see that dotted line on one side, you know what I did. If you see it on 2 sides, you know what it means. Okay. So that is how to get error in school. Please ask questions. Yes. No. It must end on the positive y-axis. If you're drawing into this part, there's no graph to plot that will go to this part. It must end on the origin on the y-axis. You will see the graphs I plotted. The graphs I plotted are, in fact, see, you see the graph, I took my time. I don't want to do this. I took my time to plot those graphs and to fill the manual from L1 to L6. So that you don't say you're making a mistake from somewhere. But the only thing I want you to do, change the statement for the precaution. Alright? But you must use one word, it was ensured. That is the physics practical language of RSU. Don't say I am sure. It was ensured. That's how I wrote it. It was ensured that need traces of this. It was ensured that this was that. I used the word, it was what? Ensured. So use that word. But it was ensured, change your own. You did GST. It was ensured, change. Don't forget yourself and copy everything. Before you copy. Even where? Don't copy like that. I'll say remind you, don't copy everything. I'll say put it down. Do not copy everything so that your mind will be there. So this is experiment L1. Let's look at experiment L3. L1 and L3 are the same thing. In experiment L1, they do not ask you to calculate error in slope. In experiment L1, they do not ask you to calculate error in slope. When they ask you to calculate error in slope, is experiment what? L2. Sine R against sine R. Let's look at L3. 1 minute, please. Alright, so let's continue. Any question? Okay, let's continue. Experiment 1, 3. Okay, so experiment L3. After L3, I'll show you how the graph looks for L4, L6. Alright, it's almost on here. Alright, so experiment L3. Alright, so experiment L3, I'm putting D against R. Alright, the scale to use is 10, 20, 30, 40, 50, 10, 20, 30, 40. Alright, so this is scale to use. Experiment L3 is a curve. Parabolic curve. If you don't know how to draw this curve, see, the best to use to draw this curve is a broom. You use a broom to draw this curve. Now listen up, please. Please listen. After making the curve, and I have my point 1, 2, 3,
4, 5, they're actually 6 points. Let's say 6.
Now look at this point. If you're asked to, in that experiment L3, they asked us to get error in N. Alright, now please listen up. How do I get my error in N? Which 2 points do I use to get my vertical scatter? Is it this? Can I use this and this? Wait now. Can I? Is it possibility? Can I use this and this?
Yes.
Can I use this and this?
Yes.
Between this and this and this and this, which one is the best? Left or right?
Right.
This is the best because they are on opposite sides. If they are not on opposite sides, that's when you take this and this. Are you following?
Yes.
Any question on this? Okay, so what do I do? I'm going to draw dotted lines. You have a question that will go through it like this. Draw dotted lines. Hope you know why I'm drawing dotted lines. Yes. Now, how do I read my value for vertical scatter? I'll place my, since I'm considering these two, I'll place my rule here, read the value on the what? Y-axis. Place it on this part, read the value. The base W is too small because they're almost on the same point. Alright? I'm just assuming. Okay, but there's C, you can never get W as 0. It can be 0.1, it can be 0.01, but it can never be what? It cannot be 0.00. Okay? How do I get I? Because this is a curve, this is not a straight line. The formula for error is so is 4W over what? And for experiment L3, how do I get this R? Is the issue. How do I get this R? You get this R by drawing what is called a tangency. A straight line that touches this chord at one point is called a tangency. A straight line that touches this chord at one point is called a tangency. Now, before you draw this tangency, please listen up. If this is the lowest point of my chord, if I place this, look at what I'm doing now. If I place this point like this, it's my rule. If I place it like this, it's my rule. If I trace it to the y-axis, please listen. From the lowest point of the chord to the y-axis, this is called minimum deviation. It means my minimum deviation is what? 40. Do you understand what I'm doing? Yes. If you trace it down like this, trace it down, this is called, when you trace it down, it's called minimum incidence. Please take notes because of exams. When you trace the curve to this point, it's called minimum what? Deviation. It means minimum deviation, it is not calculated for. It is gotten from the way? Graph. You don't calculate for minimum deviation, you get it from your way? Graph. This is my minimum deviation, this is my minimum what? Incidence. Now, after getting minimum deviation and minimum incidence, how do I get R? Range. If you look at the graph for L3 I did, it's very neat. Your work should be as neat as that. What do I do to get R? I'll place my rule to touch my core at just one point. Observe what I'm doing. This is one point of the core. I will just make a quick line like this. Are you seeing it? This line is called tangency. It's touching this curve at one point. I just made a short line. I did not say a normal line, I'll get this place. A short line. Now, after making the short line, I will use my rule, draw a rectangle triangle. Are you seeing it? Trace this from this part. Trace it down. From this other part of this rectangle triangle, trace it down. This thing I'm showing you is exactly what I did. So you won't get confused when you're looking at my work. This value here is called x2. This other place value now is called what? x1. Now, to get your range, it is x2 minus what? x1. We have gotten all the parameters from this formula, isn't it? Have we not gotten all the parameters? Yes. Anything you get, you know how, see, you know how the dot gov, isn't it? You know how the dot range, isn't it? Now, we have calculated the error is low. The next thing you need to know, from my graph in experiment L3, it will tell you what is the value of the minimum deviation. From my own graph on the board, what's my value? 40 degrees, isn't it? What is my minimum incidence? I minimum. Let's just approximate. Let's say 35, isn't it? Or should we say 37? Okay, let's say 38. 38 degrees. Now there's a part, please listen. In exam, they will always ask you to calculate minimum deviation, minimum incidence. And they will ask you to calculate something called minimum deviation of incidence. The formula for minimum deviation of incidence, ID minimum, is minimum deviation that was gotten from the graph plus A all over 2. Please take note of this formula because of exam. Minimum deviation of incidence The formula is minimum deviation plus A over 2. A is a constant. A is a constant. A is a constant value of 60 degrees. So if A is a constant value of 60 degrees, from this my graph, in my own graph, I use the value of my minimum deviation. It means in your own graph, use the value of your own minimum deviation. It means my minimum deviation of incidence. My minimum deviation here is what? 40. My A is a constant of what? 60 over what? 2. This is going to give me 50 degrees finally, isn't it? So it means minimum deviation of incidence is what? 50 degrees. I'm done with experiment L3. Who does not understand anything I did on the board? I'm talking about, I'm asking now because of exams. I'm not the type of person that will come and teach you, I will not allow you to go. Teach you, rush, go to now. Wait. Ask questions. Please ask questions. Okay, experiment L4. Which one? That's it. I don't know. If they are not. That's it. No, you have I place my rule here and I draw a line that touches the core, just a short line at one point like this. That line is called tangency. Then use your rule to draw it down, join this one to this two. When you place it down to S1, place this one to S2. So that S2 and S1 is error. You don't have a body particle scatter. That's how you get error. If you see my own thing, in my own curve is just one dotted line. If you look at the PDF, my own curve is just one dotted what? Line. The reason why I'm using one dotted line, who knows why? Because the 2 point falls on one side and not on opposite sides. Experiment L4. After L4, there's nothing much there. After L4, look at L6, please. Here. If there is a constant, it's a constant value of angle of deviation. You understand? Angle of deviation in triangular glass prism is a constant. Provided it's triangular, it's a constant. A is a constant because of the exam. They will just tell you calculate minimum deviation of incidence. If minimum deviation is this. Nobody will tell you what is A. So you're expected to know what is what. So let's talk about experimental skills here. Minimum deviation of incidence, I said from the lowest point, place it to this side. From the lowest point, place it to this side, it's minimum deviation. When you place it down, minimum incidence. Let's look at L6. I'm already very, I'm not supposed to have class today, but let's look at L6. I'm very, like, I'm not even standing there. I will tell you how L4 looks like. Please listen. Look at this. For L4, you will have 2 lines of. Please look at this. So I can just forward PDF and tell you to copy and paste. You will copy and paste what you don't understand. If I accept the PDF and you see me drawing dotted lines, you don't know why it's dotted lines. For experiment L4, you have 2 lines of person. 1, 2. My hand is not, I'm using my hand, so that's why it's not that straight. But you see the one I drew is very, very straight. Now you have 2 slope triangles. 1, 2. Look at what I'm doing. The one up is kerosene. The one down is water. You must label this. It means this line of please. It means this line of best fit. You see, when you get the slope for this one, look at it. What I'm doing is the line of best fit for water. So that I don't get it confusing or confused. Trace it to this part. Trace it to this part. Alright? So this is for water. Y2 minus Y1, all over X2 minus what? X1 is how to get refractive index for what? Water. Look at how I'm going to write it. On your workspace, the refractive index of water, you will see how many I use my own. Is equal to, what is my Y2? 0.7. I'm just assuming. But the scale I use is 1, 2, 3, 4, 5, 6, 7. You will see my own graph, how good it was, or it is. My Y2 0.7, my Y1 0.3. I've given you a link for a static index, isn't it? If you calculate your one and you're getting 3 points, 4 points. Are you correct? Thank you. Refractive index of water is y2 minus y1, all over x2 minus what? x1. Refractive index of kerosene. You trace this one. Look at this, the line of of kerosene. Please observe, my stop triangle for water is not touching kerosene. Look at where it stops. At the line of for water. The stop triangle for kerosene is stopping at this point. Observe what I'm doing. Trace this one down for kerosene. Trace it from here for kerosene. Trace it to this part. Trace it to this part. Please go and teach your customer so that they don't do rubbish. If you still want to leave them to do rubbish, no harm. Because what that thing that girl drew, forest market, was supposed to be for L4. So the factor index of kerosene, at the end of the day, you get from 1.5 to 1.7. But if you get 1.3, 1.2 something, you are correct. Why? Because the refractive index of water is slightly lower than that of block. The refractive index of water is 1.30, but that of glass block is 1.50. So anything you get from 1.3 for L4 is correct. If you look at my own value, I got 1.3, 1.34. My values, and you read it from my graph, exactly the same thing. I did not manipulate anything in my graph. Everything was taken and explained. L6, so we can call it very L6, yes. Repeat this one. The whole of L4. Wait. I should be the whole of L4. People are wicked. So, I should come and be repeating L4 like this. Please let's talk about L6. Okay, refractive index of water is 1.30, but the refractive index of glass is 1.5. Please take note of everything I'm teaching you today. Take note, please. What of what? Can I make ask you? Feel free to ask a question now. What of which one? Error. Yes, now, y2 minus y1 all over x2 minus. Okay, refractive index of kerosene. Okay, that's what you're asking. From 2 point, refractive index of kerosene is 2.0. Okay, I don't get it. I was thinking refractive index of kerosene. That's a good question. It means for water, you should get something from 1.3. For example, 1.3 to 1.5. Then for kerosene, you get from 2.0 to let's say 2.3. For kerosene, refractive index of kerosene. But the refractive index for a glass block is 1.50. Alright? For glass block is 1.50. For kerosene, 2.0 to 2.3. For water, 1.3 to 1.5. Every value I give to you is the same. I cannot tell you my refractive index is 1.3 and you're seeing my own, I'm getting 3.0. The refractive index I got for water is 1.33 for my PDF. For kerosene, I got 2.1 or 2 point something. I know it's 2.1 or 2 point something. Yeah. Is 1.4. That is when it's not mixed in water. When you mix kerosene in water, refractive index increase because it's now with something less dense. 1.4 when it is not in water, when it is just kerosene. But the experiment you have mixing kerosene and water, and you're determining the refractive index of the two liquids. So it's the refractive index is going to increase. Oh, okay. Let's L6. So I can wrap up. I'm very tired. Yesterday I had back-to-back classes. I did not sleep like a human being. So experiment L6. L6 is this thing. For L6, there's a question there. Look at this. Who did L6? Okay, please open your manual. Let's go to L6. I want you to read the questions for me. I think I've forgotten these questions so that I can get it done. Number 1, question 1. Plot a graph of d minus d squared, isn't it? Okay, d squared minus d against what? Density. Displacement d. You're plotting d squared minus small d squared against capital D, isn't it? The second question is, the gradient of the graph is -1. Let me show you how. If you're writing -1, let me show you how. It is not manipulated. From mirror formula, I think the space there. Okay, there's a worksheet for it. There's a worksheet. So let's write. From mirror formula, there's something they call spherical mirrors and plane mirrors. Unfortunately, you guys do not learn mirrors. People do not learn optics. So just connecting my optics. From mirror formula, I have that 1/focal length is equal to 1/b plus 1/what? object distance, B is called image distance, F is called what? Focal length. Should I continue? If I make 1 over V subject of formula, I have that 1 over V is equal to 1 over F. If you bring plus 1 over U to this side, it becomes minus 1 over what? U. If I rearrange it, not manipulating. If I rearrange it, I want to bring minus 1 over U to this one, bring plus 1 over F to this one. If I rearrange it, I'll have 1 over V is equal to minus 1 over what? U plus what? 1 over F. I can still rearrange this to look so that you see that it's, from here I already know that slope is minus 1. And I'll tell you why it is minus 1 in case of exam. If I rearrange it, I'll have 1 over V is equal to factor out minus 1. Please listen. Factor out minus 1. In the bracket, I'll be having 1 over what? U plus 1 over F. This expression, 1 over V is equal to minus 1 over U. Let's say minus 1. Alright, minus 1 into 1 over U plus 1 over F. Look at this, please. This is looking like Y is equal to minus MX plus C. Where slope is equal to minus 1. The slope, if I have minus MX, this slope is equal to minus 1. So if minus M is equal to minus 1, this slope minus M is equal to minus 1. If I take off this and this, what do I have? M is equal to 1. Now listen, this is how this is how this graph is to go. But the graph you have is a graph that has a positive intercept. And a graph with a positive intercept is y is equal to mx plus what? C. When you say minus mx, it means the graph is like this. It's having a negative intercept. But the graph you're plotting for L6 is having a positive intercept like this on the positive y-axis. And whenever it's having a positive intercept, it is y is equal to mx plus what? C. If y is equal to mx plus c, it means that from my deduction, n slope is equal to what? Minus 1. Slope, another name for slope is called gradient. So the gradient of this graph is minus 1 from Euro formula. That was how we got it. So if the gradient is minus 1, they said we should show a relationship. What's the third question, please? Show that what? The gradient of the graph is related to the focal length of the lens. Good. I'm looking for a relationship between the slope and the focal length. Let's not go further. Since you did not let me up to the video. Focal length of a mirror is inversely proportional to the slope gradient. 1 over slope. The slope I'm talking about is the slope from graph. So the slope you get from your plotted graph to get focal length. Focal length is my slope was 82. 1 over 82 will give me 0.00 something centimeter. That was my focal length. Focal length is 1 over the slope. Focal length is 1 over the slope. Use the same scale I used for experimental. At this point, we've come to the end of